So we have started conversion of frame. I think this is clear to you. Any doubt in conversion of frame?
Yes, sir. No, sir.
Okay, okay. If still you have doubt, you can ask me because this is very important topic. Clear? Conversion of frame. Numericals already we have discussed.
Yes, sir.
Today we are going to solve different category of numericals. So in this chapter mainly we are going to learn concept by numericals. So write down one numerical. Please write this question. Find the acceleration of given block. Question is find the acceleration of given block. Clear? This diagram I'm going to draw. Please draw this diagram. Here pulley is fixed and these are the two blocks. Clear? And here you are applying a force like this 30 Newton. Remember, this is very different question and don't worry, I will help you out. See, there are two string. On one end of the string, you are applying 30 Newton. Clear? You are applying, you are taking a string and pull it like this. 30 Newton force you are going to apply. Because of that, this block is going up. This block is going up with a acceleration and this is also going down with a acceleration like this. Okay. So here concept is that if you ask me, sir, please apply. For this case, if you draw the free body diagram for 2 kg block, so how will you draw? Like this. Clear? Tension is up. Our observer is on the ground. Nothing is given, always take on ground. Clear? It's our observer. Clear? Now here, if the concept is that, do you see any weight here? This is the end of the string. Okay, there's the end of the string which is massless. String is massless, and at this end I just applied 30 Newton down. Then tension will be up. If you draw the free body diagram of this,
Yes, sir.
it will be what? 30 down and tension is up. Then how will you write the Newton's law of equation in x and y direction for both the things? This is first 2 kg. Okay, how will you apply? You have observed, observer is here, draw x and y here, x and y like this. Clear? Now apply the Newton's law of equation. Simple. For this 2 kg block, T is up, 2g is down, 2g means g is 10, 20. Clear? Mass
Yes.
2 into a. Is it clear? Equation 1.
Yes, sir.
F is equal to ma. Simple. Net force is equal to mass into acceleration. For this case, you are applying T is up, 30 is down, but string is massless. String is massless like this. Then what is the answer you are getting? Elimination method if you apply minus plus minus. Cancel 30 minus 20 that is 10 and 2a minus 0 into it is actually 2a. So what is the answer you are getting? 5 meter per second square.
5.
So concept which what we have learned here, no need to apply the second equation like I have applied t minus 30 is equal to 0 into a na. No need to apply. concept is that if you apply, in what case, here did you see one thing, that one thing, even I have one more way to explain this. First you write this, then I will explain one more way.
Completed, sir.
Completed. Okay, acceleration you got. See, while solving such numericals, there is a concept that you can apply the detail by detail concept, but I'm telling the in short way, simple concept. If you ask me, sir, here you have applied a force like this. If you pull it down with a force 30 Newton, and this is 2 kg. Now see, you are applying 30 Newton directly. You are applying 30 Newton directly on a string. Okay, directly on a string, and it is along a string. Two things I'm saying. You are applying this 30 Newton like this directly on the string, and it is along a string. Then in this case, the tension in the wire or a string will be equal to what? Applied force. Clear? Concept is that. I will also write. Then simply draw the free body diagram of this. You will get the acceleration t minus 20 equal to 2 into a. Tension is equal to applied force. 30 minus 20 is equal to 2 into a. So what is the answer? 5 meter per second square. Clear? Now, so concept what we have learned, you can write.
Yes, sir.
You can write also. Force is applied. If you want to write, you can write. Force is applied directly on a string. Force is applied directly on a string. Directly on a string and along a string and along a string is equal to tension in a string. Tension in a string. Clear? I hope you have written. Clear? Okay, you're
Yes,
writing?
sir.
Okay. Now see, if we are having, this is a pulley. Let us suppose this pulley like this.
Sir, can you show that last slide once
Ah,
more,
sure,
sir?
sure. Please write.
Completed, sir.
Okay. See, if a string is attached like this, and if you apply a force like this, then this force is not equal to tension. Remember, you can't say. This force is also directly applied on a string, but this is not along a string. Two conditions there. Force is applied directly on a string, and it should be along, means in the direction of string only. Clear? Then only we can say force applied is equal to tension in a string. But here you can check, I have applied a force like this, but the string is like this. So here we can't say F is not equal to tension. Few cases I just want to explain. One more case, like for example, this is a case. One block is here. One more block is here. Let us suppose M mass. Clear? Now if you apply a force like this, F is equal to 2 mg. You are applying this much force. You can't say this force is equal to tension. This force never equal to tension. Still, this is along a string, but this force is not directly on a string. In between this force and a string, there is a block. Okay, understood? Directly, you should
Yes, sir.
take a string and pull it down. Then you can say force is equal to tension. In between you and the string, somebody is coming. Like here, block is coming. We can't say that. Clear? We can't say that
Yes,
here
sir.
force is equal to tension in a string. Clear? Here also
Yes, sir.
F is equal to 2 mg, which I have written, is not equal to tension. Clear? So force
Yes, sir.
must be directly on a string and it should be along a string. That is the condition. Clear? Understood? Okay.
Yes, sir.
Next category of question like they can ask in an exam. Right, so write with the problem. Okay. Question is find the acceleration of given blocks. Find the acceleration of given blocks. Given blocks. So you are having a pulley. This pulley is attached by two blocks like this. This is 2 kg and one is 3 kg. Both are like this. And they are resting on the ground initially. Now this pulley, you are applying a force on this pulley. Now my question is, if you apply this much force on the pulley, then what is the acceleration of given blocks? What is the acceleration of given blocks? There's the question. Clear? Here you can consider one observer is here on the ground. Clear? This is the observer. Clear? Please do. Find the acceleration of given blocks. Let us solve. First, let me solve, then whenever you are going to practice, this will help you. Okay. For 2 kg block, if I ask for 2 kg block, you tell me if you are applying 20 Newton here, then if you draw the free body diagram of this pulley, then how will you draw on this pulley? One tension will be
Force upwards, tension downwards.
like this, na, very good, downward. So how much tension? TT, 2T, and force
2T.
is 20 up. If you ask me, sir, please find the tension in the string, you can find 2T equal what? 20 is up, 2T is down, mass of pulley is negligible, acceleration whatever else, even it is there or not, it will be 0. So we can say tension in the string is 10 Newton. Understood? Now you just
Yes, sir.
tell me 20, gravity is pulling with 20, 20. Now this, when you apply 20 Newton, when you apply 20 Newton on the pulley, then how much tension is given by how much tension in the string? 10 Newton. Here also 10 Newton. 10 Newton. Similarly here 30. 30. Here 10 Newton. Clear? Tension in the string. Now tell me if you take this pulley with what force? you are pulling this pulley with 20 Newton force you are applying on this pulley. Then how much tension in the string? 10 Newton, 10, 10. 10, 10 Newton will be felt by the 2 kg and 3 kg block. Okay. Now
Yes,
my
sir.
question is this 10 Newton, 10 Newton is sufficient enough to take this block up? Gravity is applying 20. Since tension force is less than gravity, then there is no acceleration. Understood? There is no acceleration
Sir,
in
but
2
only
kg and 3
individual
kg block.
tension force.
Yes?
Sir, but individual tension force is only less than gravity, right, sir?
Yes, yes. You tell me, you have a this span. This span has 20 Newton weight. It is acting down. You take a wire, you take a wire and you are applying 10 Newton to pull it up. You want to accelerate this
Oh,
pan with 10 Newton. Is it possible?
no, sir.
Will you like you are able to, you can't move it neither up nor
Yes, sir.
right,
Now I
nothing
got
else.
it.
You can't move this. This span on this span 20 Newton is being applied by the gravity. And you are in the top direction, you are going to apply how much? 10 Newton. Then will you see the span will accelerate in the upward direction?
No, sir.
Will this pulley is sufficient enough to take this block? No. But if you apply 40 Newton on pulley, then there is a possibility. If you apply 60 Newton on pulley, then tension will be 30 Newton. Then there may be a chance of acceleration. But in this case, since tension is less than the weight. Understood?
Yes, sir.
10 Newton with the help of rope. For example, this is the rope. Clear? Just see. This is 20 Newton. Mass is 2 kg. And 20 Newton I have applied. This is gravity. My hand is gravity. Okay. I'm going to like this. I'm going to pull it down like this. 20 Newton I'm going to apply. And at the top, string has tension. How much? 10 Newton. Clear? It is 10 Newton. Now tell me, is this 10 Newton which is being applied by the string is sufficient enough to move this block up like this? Tell me. No.
No, sir. Not sufficient.
Because downward force is 20 Newton, you are
Not
applying
sufficient.
upward force is 10 Newton. The net force will be in the downward direction. Downward direction. If there is no surface of the earth, then this block is going to the center of the earth. The surface of the earth is providing normal reaction force. Then who is going to balance the remaining force? Normal reaction. Clear? So first of all, before drawing the free body diagram, always check such condition. Such type of question also they can ask. Clear? So both the blocks A1 and A2, their acceleration will be 0. And they are having the acceleration 0, then this pulley is movable. So you can write AP is equal to A1 plus A2 by 2. A1 is 0, A2 is 0, then pulley is not accelerating. Understood?
Yes, sir.
Now you can find the normal reaction force. If you draw the free body diagram of 2 kg, 20, 10, okay. Normal reaction on this will be where? Up or down? Tell me. What is the direction of normal reaction on this 2 kg block due to surface of the earth? Up or down? Tell me. Up. Clear? Understood? Hello? Am I audible? Hello? Is my voice audible to you? Hello? Your voice is, I think, you are on mute. Is
Sir,
my
your
voice
voice
audible?
is not audible.
Okay, my voice is not audible to you? Is it audible
Sir, your
now?
voice is not audible.
Okay, 1 minute. Let me. So is it clear to you? See what I'm saying here. Look at here. In this question, like if you draw the free body diagram, 20 is down, 10 is up, the normal reaction on this block will be up, N1. Clear? Similarly, for 3 kg block, if you draw the free body diagram, 30, tension will be up, not clear? 10, tension normal will be N2. Clear? Now, if you apply Newton's law of equation here, then it will be N1 plus 10 minus 20. There is no acceleration, so net force will be 0. So N1 will be what? 10. Understood? Similarly here N2 plus 10 minus 30.
Yes, sir.
This will be like, because acceleration is 0. So directly I can balance the force. Even you are not solving like this. Now you can tell directly. Since now block is at rest, both the block is at rest, then normally you can tell directly, even without solving also. Clear? Now please, next question also I'm going to give you. Solve that. Shall I give you one more question? Okay. Keep taking notes because these notes are very
Yes, sir.
important. Draw this question, draw the figure. Next problem. Same question, but you have to understood like which block has acceleration, which block is not having acceleration. Okay. This is the case. 2 kg, 3 kg. Tell me the answer. Clear? Could you please tell me what is the direction of tension force in this pulley? How much tension in the string? If you are applying 50 Newton,
Down
very good.
2T.
Down.
2T
Yes, very
tension.
good. T 2T. 2T. Then 2T minus 50 is equal to 0. T will be what? 25. Is it correct? So tension in the string will be half of
Yes, sir,
the
correct.
force applied on the string. If you apply 100 Newton on the string, not a string, pulley, directly. Clear? If force is applied directly on massless pulley. If you want to write, you can write this concept later. You can write. First, tell me, in this question, like which block is having the acceleration? 2 kg, 3 kg. Check here. Weight, gravity, 20 is down. M into G. Here tension is how much? 25 Newton. Clear? Here weight 30 and tension the string on this block 25. Now tell me, in this case, according to you, which block has acceleration? This block or this block? If I say acceleration of this block is A1,
3 kg
acceleration of
block.
this block is A2, magnitude, then which is 0 and which is not?
2 kg block is 0. 3 kg block is not.
Tell me. Look at the
Sir, can you
diagram
hear me?
carefully. Yes, yes, tell me.
Sir, 2 kg block will not have any acceleration. 3 kg block will have acceleration.
Okay, according to you. You tell me. This is 2 kg block. Okay, this 2 kg block. 2 kg block weight is 20 Newton down and 25 Newton is up. The net force will be up now. It is going to accelerate. It is going to accelerate now. 5 Newton is up.
Ah, okay.
So once Tries. Please think.
Yes, sir. I think I got confused.
Yeah. Now 3 kg. Check 3 kg. This is 3 kg. 30 is down like this. And 25 is up. Then which is more? Net force will be in which direction? Down or up? Down. Down means
Downwards.
it will remain on the ground. If there is no surface of no surface, then it will break that. If there is no normal reaction force, then it will not be balanced. Okay. Then who is going to balance that remaining force? Axis is 5 Newton. Who is going to balance normal reaction force? Understood? Now you just tell me this surface
Yes, sir.
2 kg block, 20 is down and string is providing 25 is up. Clear? Now tell me this block will leave the contact. It is going up. And you know that normal reaction force acting only when there is contact between the two bodies. If there is no contact, there is no meaning of contact force. Understood? Even friction, normal. So you just tell
Yes,
me,
sir.
if you draw the free body diagram of 2 kg block, how will you draw? For 2 kg block, mg is down. Clear? Tension is up. Very good. 25 Newton. I'm writing directly, okay? Because I just found. You can write T also. No worry. Now, any other force which is going to act? No. No other force. You can't say normal reaction.
Normal. Sorry,
Normal
sorry.
will not.
In
Normal
3
will
kg
not be
only.
there
3
because
kg only normal.
yeah, there is no contact. It is leaving the contact. It is going up. This is for 2 kg block. Understood? Now for 3 kg block,
Yes, sir.
if you draw the free body diagram, one is M into G like
mg
this.
upwards 25
Very
in
good.
Newton
25 is
and
up
n upwards.
and N will be where? Up. Very good. Now you can apply the Newton's law, Newton's second law, and get the value of A. Clear? If you apply for this 2 kg block, if I apply, then what is the equation you will get? 25
Sir,
is
is the
up.
answer 2.5 meter per second square?
Very good. Nice. 2.5 plus 2.5 means it is going up. 2.5 meter per second is very nice. For this case, in this case, there is no acceleration. Its acceleration is 0. But you can find the acceleration is 0, then N2 will be what? N2 will be 5 Newton. Understood?
Yes, sir.
Any doubt in this question?
No doubt, sir.
Okay. Shall I ask one more question?
Yes, sir.
Okay. Now see. Now you can write the concept also. Write the concept. If a force is applied, if a force is applied directly on a massless pulley, directly on massless pulley, massless pulley, massless pulley along a string. If string in Y, you are applying force in Y also. Then tension in a string passing over the pulley passing over the pulley is half of the force applied. Is half of the force applied. Clear? This is the concept. Have you written?
Yes, sir.
Okay. The same thing I can show you in the previous question. Here, how much force you are going to apply directly? This force is applied directly on a string. 15, not a string, pulley. Massless pulley. How much? 50 Newton. Clear? If a force is applied directly on a massless pulley, then the tension in the string which is passing over the pulley will be what? Half of the force applied. 50, 25, 25. You can check. 25, 25. But condition is that this force which is you are going to apply, the force which is going to apply, it should be along a string. You can check a string is this like y. Clear? Then it should be in the y. Like that only. Clear? So if a force is applied directly, the concept which we have learned, the directly on a massless pulley, along a string, then tension in the string is what? Half of the force applied. Now write one question. From this question, like a lot of things will be clear. Draw this diagram. This is a pulley. Okay, like this. Okay, one more pulley. Like this. Don't worry, my drawing is not okay. Clear? So no need to go there. Like this. Hmm. You need to tell me the value of this force. Okay. String is, you, see, where is string? I just want to explain. String is this. This is string. I want to highlight. String is this. It is going to pass like this. Again, string is there. String is there. Okay. Like this. Somebody is taking, pulling it directly. He is pulling the string with a force I have, which is 30 degree. Now you need to tell here mass how much. You can write 1000 kg like this. So in this case, you need to tell me find the value of this force. Clear?
Yes, sir.
Easy question only. Just I want to explain. Very easy. Find F. You tell me. This is different string. Clear? Here, if you draw the free body diagram of this string, this is this pulley. This pulley. All system are in equilibrium. Okay. This pulley. Can you check this pulley? Clear? If you draw the free body diagram of this pulley, then tension on this pulley will be like this. This is T1. Here T. Here also T. Clear? Now, if you draw the free body diagram of this,
Yes, sir.
1000, then here T1. Clear? And gravity is also applying. How much? M into G. M into G. Clear? Then all the system are in equilibrium. So can you, if you apply Newton's law on this, then can you say T1 is equal to what? 10,000 Newton. There is no acceleration. Huh? Understood? Now, if you
Yes,
draw
sir.
the free body diagram of this on this pulley, this tension is going to apply directly. Force is applied on a string. This T1 is going to apply directly on a pulley, massless pulley, and it is along a string. So you can say this T will be half of T1. Or even if you want to apply, you can apply the Newton's law and get the answer. Free body diagram, T1 up to T. Clear? Then you can say 2T minus T1, mass of pulley is negligible. So can you check? T will be what? Half of T1. Then it will be what? 5000 Newton. T1 value. Oh, sorry, T. Understood? Clear?
Yes, sir.
This question is, I can solve directly, but I want like you should watch it carefully, okay? See here. Now for this pulley. For this pulley, if you draw the free body diagram, tension is will be like this T. Here tension is T2, T2. Clear? Understood? Now if
Yes,
you
sir.
draw the free body diagram of this pulley, it will be what? T is down, T2, T2 up, 2T2. Clear? So 2T2 will
Yes,
be what? Minus T equal to 0. So simply half of the force applied on the pulley. How much force? T is 5000 Newton. So it will be what? T2 will be what? 2 to the 4, 2 5 the
2500.
10, 2500 Newton. I am solving like this. But in exam, you can solve directly. Simple half. Tension will be half of the force applied on a pulley. That is the concept. If you are applying 1000 Newton, it will be 5000 on the string. If you apply 500 Newton on the pulley, then 250 Newton on the string. Clear? Now this
Yes, sir.
T2, you can check. Everywhere string is there. String is everywhere. String is all around. Somebody is applying force F. Clear? Then what concept you have learned
Yes, sir.
previously? What is the concept? If you apply a force directly on a string, then force is equal to
The
what?
same string is equal
Very
to
good. F
tension.
will be what? T2. T2 is what? 2500. This is the answer. Concept, how much use of a concept? Can you check what we have learned? If you go back, this concept we have learned force is applied directly on a string. This concept has lot of variation. There lot of application. Force is applied directly on a string and along a string is equal to tension in a string. Clear? Understood? So this question, I think it is clear
Yes,
to
sir.
you. This is a really good question. And if I ask like one more question to you, first you write this, then I will ask last question to you. Then such type of problem we will solve. We will finish. And in the next lecture, I will discuss like how to find like reading. Okay. When you like in a lift, if you take any weighing machine, then how much reading is given by the weighing machine? Such concept, such type of problems you will face like in your competitive exam. So you have written this.
Yes, sir.
You
Completed.
okay? Now write one more question. This question you have to give me the answer. Draw this figure. Please draw. This is support, okay? And here like we have attached a weight 10 kg. You need to find the value of F. Find F. Tell me.
Sir, force 50 newtons, sir.
Force is like 100, half, 50. Yeah, correct. 50. Very nice. Correct. I think you understood. Yeah. I think you
Yes, sir.
understood. Category 4 type, category 4, category 5. Two categories are left to done. Clear. Then all the categories will be finished. Then we will move to the friction. Okay. This will take time. Okay. Numericals we have to solve in this chapter. Until we solve, chapter is almost finished. F is equal to ma. That's what we have learned. Okay. Now it has lot of application like. So I am going to finish that only. So in the next lecture, I will discuss like reading on a weighing machine, such type of problems. Then friction. After friction, I will move to the circular motion. Then circular motion. Then this is finished. First part. Clear. Then we will move to the
Yes,
work and
sir.
energy and kinematics. Okay. So thank you so much. And tomorrow also, I think tomorrow you have class or not? Maybe day after tomorrow you have class. Okay. No class tomorrow because I have one more class tomorrow. Everything is balanced. Today, actually, we have a holiday now. That's why only I kept this timing. Otherwise, it's not possible. Like, too much busy. Like, how can I say? Like, now, like, pre-board exam finish.